Okay, let's look at number 6 over here. So this is a pretty difficult problem. Um, so a rock falls from rest a vertical distance of 0.72 meters to the surface of the planet in 0.63 seconds. The magnitude of the acceleration due to gravity on the planet is blank. Okay, so let's start off with our guess, G. The things that we're given. We are told that it falls from rest. So that is going to tell us the first thing, which is our initial velocity is equal 0. Don't be fooled on this one and thinking that the gravity is 10 because we're talking about the gravity on some other planet. And so we're trying to find out what that is. So the initial velocity is 0. The distance that it falls is 0.72 meters, and it does so in a time of 0.63 seconds. Okay, and then the unknown, what we're looking for is our acceleration. Okay, so if we try to find a equation that has all four of these, we're not going to find one. So we need to go back to what we're given and see we have initial velocity, we have distance, and we have time. And kind of look at our formula sheet and see what we can get from that. And if we look and we see that we have distance and time, we can see from our formula sheet that velocity is equal to distance divided by time. One thing to be careful about, though, is that this is the average velocity when we do that. And so it will not be our final velocity, but our average velocity. So if I plug into this one and I say that a distance of 0.72 meters divided by 0.63 seconds, I'm going to come up with an average velocity of 1.14 meters per second. Okay, so again, this is our average velocity. So I'm going to run you through something real quick to try to explain why that is not our final velocity and how we're going to get our final velocity from that. So if I have an object, then I drop it, its initial velocity is equal to 0. And if I drop it and it falls for, say, a time of 2 seconds, we know down here that the final velocity is going to be equal to 20 meters per second because acceleration of gravity, 10 meters per second per second. If it falls for 2 seconds, it will go after 1 second, 10, after 2 seconds, 20 meters per second. In that time, it will fall a distance of 20 meters. Okay. So if I were doing my formula we just used and said distance divided by time, I would get 20 divided by 2 equals 10. And so you can see that that 10 is certainly not the 20 for our final velocity. This is, again, our average velocity in meters per second, and it's because it started here at 0, it ended here at 20, so on average, it traveled at 10 meters per second. So if I want to go from my average velocity to my final velocity, I've got to multiply by 2, okay? So I have to do that over here. I have my 1.14 meters per second. I've got to double that and come up with 2.28 meters per second for my final velocity. Okay. So now I can plug that into my givens. I'm going to erase this over here so we can move on now to our next part of our equation. So I'm going to call this equation 1, and over here is going to be equation 2. And so again, we're trying to find acceleration. If I want to find acceleration is equal to VF minus VI divided by T. Okay, so now let's scroll down here a little bit. So now I have to start to substitute in. I'm going to say my acceleration is equal to my final velocity, we just found to be 2.28 meters per second, minus my initial velocity, which was 0, divided by the time it took, which we had as 0.63 seconds. And then so if I do that out, I get 2.28 divided by 0.63, and I'm going to come up with 3.6 meters per second squared. And that is my answer.